Hello, and welcome to this video presentation. My name is Paul Brett. I'm a Senior Software Support Analyst supporting the Transformation Extender product from IBM. The topic for this video is Custom Conversion Step by Step. Feel free to reach out to me on popular social media channels at Paul Brett Tech. This video was inspired by an actual customer request. I wanted to highlight the building block nature of the process of producing the data mapping, going from getting a character to work first, then a string. Building mappings this way, testing at each stage, can have benefits to your sanity. I made mistakes while creating the data mapping, and I want to highlight those as well, going through reasons and potential solutions. The basic rules of the mapping are: the input is UTF-8 and the output needs to be UTF-8. However, any UTF-8 character that cannot be found in EBCDIC code page 1141 needs to be substituted for the hex string representation of that character if it were expressed in UTF-16. My example input string, the first character is one such character. Although it can be expressed in UTF-8 and UTF-16, it will not be found at all in EBCDIC code page 1141. So in my output you will see it has been replaced for 0171. Every other character is exactly the same. We will begin this demonstration in the ITX Design Studio. Today I'm using ITX 10121. As you can see, I have a new workspace where I've created a single project called Custom Conversion, and within the project we have just two files at the moment, input.txt and input.char.txt. In my Windows File Explorer you can see that input.txt contains the string that we want to convert today. We already know that every single one of these characters is expressed in UTF-8, as shown by a notepad here, and all of them, bar the first one, can be expressed in EBCDIC code page 1141. The first one cannot, unfortunately, and at output we are expecting this to be replaced with 0171. Input char.txt contains just the first character. So for our mapping today we are going to build a map that will convert one character at a time and do the business rules that we want. If the character can appear in EBCDIC code page 1141, it is to be copied exactly as it is an input as UTF-8. If it cannot be expressed in code page 1141, it needs to be converted to UTF-16 and then expressed as a stream of bytes. So let's create that first map now. Let's create a map source file, and within that create our first map. I'm going to call it test char. Before we can create any input cards, we're going to need some type trees. So let's create those now. My first type tree is going to be called UTF-8.mtt, and within there I'm going to create one object. I'm going to call it UTF-8 item. I'm going to change its value of class from category to item. And then let's change its national data language from native to UTF-8. I'm also going to create a second object called UTF-8 char, changing its class from category to item again, data language to UTF-8. This time I'm also going to set a maximum size of this object to be one character. My type tree is complete for now. I'll come back and create additional items in here later as I need them. I could of course create all of these objects in one type tree, but for simplicity's sake I'm creating a single type tree for each type of data language. From the tree menu I'm going to analyze structure and logic and then save the file. Now that we have our single type tree, we can create our first input card in our map. Our input card is going to be called 1UTF-8 char because that is exactly what it is going to contain, and it is best to create your type trees with card names that match the content. The type tree we're going to use is the one we just created, The object we're going to use is the char object. We're going to read our file that contains just one UTF-8 character, and we can now save, build and run our map to ensure that the input type tree correctly reads the input. Now we need to convert that data into EBCDIC 1141 to see if it actually exists. So we're going to need a new type tree first, so let's create that. Within this type tree I'm going to add one object. I'm going to call it EBCDIC item. In properties I'm going to change the class from category to item, and then I'm going to change the data language from native to IBM 1141 EBCDIC DE 273 plus Euro, which is the closest match and suits my purposes perfectly. From the tree menu, analyze structure and logic, and then we save this file and close it, and now create an output card in our map that is going to use that type tree. This is a temporary card, so I'm just going to call it out1. The type tree I'm going to use is the one that I just created, EBCDIC 1141. The only object in there, EBCDIC item. And I'm going to write to outtemp1.txt. Drag and drop my input, and this is going to do my conversion for me. And if I save, build and run, you'll see that the file has appeared, outtemp1.txt. And over in the File Explorer, you will note is 0 bytes. This tells us that that one character that we have used does not appear in EBCDIC 1141, and therefore we have 0 bytes. Just to prove that a character that does appear will appear in the output, I'm going to temporarily remove that character and replace it with a Z. I'm going to run my map one more time. Map completed successfully. And in the File Explorer, outtemp1 you will note now contains content. It shows there's 1 kilobyte, but it's actually 1 byte. If we bring up the properties, it contains 1 byte of data. So let's put our input char back the way it was, because we need to do the rest of the business logic. We also need a UTF-16 representation of this data, so we're going to need another output card, and that's going to need another type tree. Let's create a new type tree file. I'm going to call it UTF-16.mtt. I'm going to create one object within it called UTF-16 item. In the properties, I'm going to change the class from category to item. And I'm then going to change the data language to UTF-16 little endian. Now this is the mistake I was talking about earlier. This is the wrong data language to choose. It's the mistake I made the first time I did this map, but I want to show you what happens when we make this mistake and the two ways that we can fix it. We'll come back to that later. So if we analyze structure and logic here, save and close, and then let's create our new output card. This is another temporary output card, so I'm just going to call it out2. The type tree we're going to use is the UTF-16 type tree. The object is going to be the UTF-16 item, and we're going to write to outtemp2.txt. I'm going to drag and drop the input to the output again. I'm going to save the file. I'm temporarily going to close the file and delete some temporary stuff, and then reopen the map so that the cards are in the correct order. Out2 is now here, and if we build and run this map and have a look at the output side, we have outtemp2. It shows as garbage for me because my version of Notepad will not recognise UTF-16, but it's got 2 characters in there, so at the moment I'm going to assume it's right, even though I actually know it's wrong. And we'll create our output card 3 to get the hex representation of those to see what they are. Now I could also bring it up in Ultra Edit and show it in hex mode to show it's wrong. We'll do that now briefly. As you can see, we have 7101, and we was expecting 0171. But we'll ignore this mistake for now and we'll fix it in a bit. Next we need another temporary output card, out3. But before we create that, we're going to need a new type tree object. So let's create a new type tree file. We're just going to call this generic.mtt. Going to have one object called text item. I'm changing it from a category to an item. And we're just going to leave it as native. That's fine, that can stay exactly as is. Analyze structure and logic, and then save that type tree. A new output card. Another temporary card, out3. It's going to be using generic.mtt, text item, and of course writing to out temp3.txt. I'm going to save, close the map, tidy up my workspace, and open the map again so that the cards are in the correct order. 1, 2, 3. Okay, in 3 I'm going to want the content of output card 2, which is the UTF-16 representation, and then I'm going to want to apply a function to it. So if I go into the rules, insert functions to get the functions tab up, and the function that we want is stream to hex text, and I drag and drop that onto that object. It surrounds the object automatically for me, and if I save, build and run this map, we can now see that we have out temp3.txt, we have our string of hex bytes, and it's at this point, if you didn't have a hex editor, you would see the mistake that was made earlier. Now there are two ways to fix this issue. The correct way would be to amend the type tree and fix the type tree to be the correct endian for this object. But there is another way as well. Instead of taking the raw object out2, if we apply a reverse byte function to out2 and then surround that entire thing in the stream to hex text, save, build and run. If we look back at that file now, out temp3.txt, we have the correct result. This is what we wanted in the first place. However, as I said, this is the messy way of doing it. So let's fix it properly. Let's change this map back to the way it was, not using reverse byte, and fix this object UTF-16. We'll open the type tree. We'll look at the properties of this object, which is currently UTF-16 little endian. We shall change it to UTF-16 big endian. Analyze structure and logic one more time because we've changed something. Save it. It asks if you want to update the map. I click on yes. And then this is now a UTF-16 big endian object. The stream to hex text should work perfectly and give us the result we need. Save, build, run. We're doing no reverse byte this time, but we have the correct answer in our output file. Okay, so now we come to the final card. Now this is a card that is going to hold a UTF-8 character. Potentially, instead of a UTF-8 character, it might be a stream of hex bytes. So we can't use this UTF-8 char object in our output card. But fortunately, if you remember when we created UTF-8, we also created this UTF-8 item, which is not restricted to one UTF-8 character. So we're going to be using that object in our final card. So let's call our card final to match the content. The type tree we're going to use is in UTF-8.mtt. It's going to be the object UTF-8 item. Remember, we can't use char because it might contain more than just one character. And we're going to write to a file called final.txt. Now here's where we put our business logic. I'm going to save the file, close it, do the cleanup, and open it again so that we have got our cards in the correct order. And our business logic is if size out1 equals 0, i.e. if it's been transformed from UTF-8 to EBCDIC code page 1141 and it doesn't exist, then you need to put in whatever we find in output card 3, which is the stream to hex text of the UTF-16 representation of the data. However, if it's bigger than 0, i.e. it does exist in EBCDIC code page 1141, what we want to drag in is the input again. one UTF-8 char. So that's our business logic. If we save, build and run this map and then look at the final.txt, we get 0171. Now if our input was input char, if our input single character was in fact a different character that can be represented in EBCDIC, when we run this map, what we want final to show is that single character, which it does. Let's go and restore this back to the weirdo character that can't be represented. And we run this map. That's when we want not that character to come through, but the hex representation of the stream to hex text of the UTF-16 object. So now we have our map completely working with our business rules for one character. The next step is to create a top-level map that reads in those characters and then drops to a functional map for one character at a time and calls this run map to convert each character as required by the business rules and then give us the final string. So that's the next step. So over in our map source file, let's create a completely new map. I'm going to call this map test string, the original map being test char. In test string we need to read the entire string, and we have an object called UTF-8 string, but this is no good to us because what we need is an object that will allow us to loop around in a functional map. So that means creating a group object. So let's do that now. We'll open our type tree and we'll add a new object called string of UTF-8 chars. In properties we need to change from a category to a group. This group is going to be an implicit group. There's going to be no structure to the group itself, and it's going to use the structure of the individual items to work out when a new object is started. So if we double click on this group and say that it's going to contain UTF-8 characters, dragging and dropping allows one of these objects to appear. If we right click and choose set range, we can say that it could be 0, but it could be infinite. So we're doing the range of 0 to S. Closing the group, saying yes, we want to save those changes. From the tree menu we're doing analyze, structure and logic. There's a warning that pops up that says different data objects may not be distinguishable. Well, I know they will be because each UTF-8 character will be popped into the object exactly as I expect, so I'm going to ignore that warning. I'm going to close the type tree after saving it, and in our new map test string I'm going to use that type tree in a new input card. My card name is going to be called input UTF-8 string. My type tree is going to be UTF-8, and the object I'm going to use is the one I just created. The file we're going to read is input.txt, which is the file that contains the full string. Now the string is going to be read into the group object, but every single character of that string, no matter how many bytes it is in UTF-8, will be read into this object. Now on the output side we need a similar structure to loop around and do the business conversion for each one of those. However, we can't use the same group, and the reason is because on the output we might not have a UTF-8 character in each object. There's occasionally going to be a string of hex bytes. So I need to create yet another object for use. So I'm going to open my type tree again, create a new object, call this string of UTF-8 items, different from a string of UTF-8 chars. In the properties I'm going to change from category to group. Again, it's going to be implicit. I'm going to double click this. I'm going to drag in UTF-8 item. Now remember, this can be a string of any length here. I'm going to set the range from 0 to S, close to save these, and in the tree menu analyze structure and logic. We get some additional warnings. The second warning that says that items in string of UTF-8 items may not be distinguishable. Now this is a genuine warning that you would be concerned about if this was an input type tree. Because if you was reading in the string 0171, it wouldn't know if the 0 was the start of a string of hex bytes or if it was just a single UTF-8 character. So this type tree object here would be absolutely no good to us on an input card at all. But on an output card, totally fine. We can build the business rules and it just populates it with what we want. So I'm going to analyze the structure and logic one more time and then save the file and close that, and then I'm going to create my new output card. I'm going to call the card output string. The object I'm going to use is the one we just created in utf8.mtt, string of utf8 items, and the file I'm going to write is called output.txt. This is the final output that we're going to create, output.txt. Okay, so we've got a repeating group on input, a repeating group on output, so we're going to need a functional map call. Drag the object across and enclose it in a functional map call. It will show as a functional map that is not created. If I right click and choose a functional map wizard, I can create that functional map. The icon changes, and then I can double click to drop down into the functional map and do my mapping that calls the run function. So on the input card here now we have one input character, one UTF-8 character. We need to send this to our run map. So our run map call is the name of the map and then the arguments to that map. Now we're going to be echoing in the input character to input card 1. And we're going to be retrieving the contents of output card 4. Now this is the basics of my run function complete. This is, however, going to make a complete mess of my input. And the reason is that this object here is UTF-8. I've used it in my echo in. In any run function, if you're sending data to a submap, it is going to try to convert it to native before it sends it, if it's not already native. This is a bad news because my submap is expecting UTF-8 data. I'm going to show you how badly this messes up by saving, building and running this map, and I'll show you what the output file currently looks like. Many of my characters have completely gone missing. Okay, so we know that we need to put an additional function in here to say do not do that additional conversion. I want you to treat this character as already being native and don't do an additional conversion. So this is now going to send the raw bytes. It's going to C package with native as the second argument. It's going to tell the engine this is already native, don't change anything, just send the raw bytes exactly as is. Now the data that we get back, it's going to assume is native. It's writing it into this object which is UTF-8, so it's going to do another conversion. And this is bad news again because the data we're getting back is already UTF-8 and we're going to get a double conversion, so the output is again going to be garbage. So let's see what happens when we do that now. If we run this map and look at the output file, my input character has now arrived correctly in the run map and come back correctly as the 0171 that I want, but the other special characters have had a double conversion and it's made a complete mess of that. This does not look anything like the input string that we had. So let's close and fix that problem. So the return from this run function needs to be wrapped in yet another C package to ensure that it does not get converted. I'm going to say that the data is already UTF-8. Don't do an additional conversion before writing it out into this object. If I build and run this map now, we have our final output file, output.txt, which is our exact copy of our input string, apart from the one character that could not be represented in EBCDIC code page 1141, which is now represented as a hex string from UTF-16. So this is now a fully functional map that matches our business rules. I want to thank you for taking the time to watch my video presentation today. If you found the content interesting and informative, hit that like button. Perhaps leave me a comment. Consider subscribing to my YouTube channel, as I release content such as this on a regular basis. Feel free to reach out to me on popular social media channels at Paul Brett Tech. Thank you.